All right. Rotate a matrix. Okay, given an image represented by an n by n matrix where each pixel in the image is represented by an integer, write a method to rotate the image by 90 degrees. Can you do this in place? Um, okay, let me think about it. Alright, so copying this guy out. I should really just make this as like a template or something so I can just keep using it. Chapter 1 problem 7. Rotate matrix.clj. Alright, so it takes a matrix M. Alright, so it's an n by n matrix too, so it's not. I don't know if I read it out loud, so I'll read it out loud. Rotate matrix. Given an image represented by an n by n matrix where each pixel of the image is represented by an integer, write a method to rotate the image by 90 degrees. Can you do this in place? Okay. Expected rotate matrix. Let's see. Let's see. Alright, so I feel like I can just zip across the matrix. And that would... If I have a 4 by 4 matrix and I want to rotate it, that means I basically want to... I'm doing stuff with my hands here, but I want to turn it 90 degrees. Which means that what is in the top right corner should now be in the top left corner, basically. The last item in the first row should now be the first item in the first row. I'm not too intuitive about this. I never really did a whole lot with matrices, honestly. Alright, but... Okay, so we have an n by n matrix. Is that... I mean, that makes it easier, I think, because now I think we don't have to worry about, like, matrices shortchanging themselves. First of all, in reality, if you had this problem, you should go look up a library that lets you just import matrices, and you should just use the operation there. But if we're going to write it ourselves, I think we have a matrix, which is just a 2 by 2 vector, right? And so I feel like maybe we just want to map how do I invert a matrix? How do I rotate a matrix? I don't even actually quite understand what inverting a matrix means, honestly. What is inverting a matrix? Okay, I think I get this concept. ADVC. So I leave the diagonal alone, and I negative everything outside of it. Okay, so inverting a matrix means is the same thing as a numbers inverse. Why don't they call it inversing a matrix then instead of inverting a matrix? Oh, they do. Wait, did I mistype it? What is inverting? Well, I don't know. Anywho, we don't want to invert anyway. We want to rotate. And so, yeah, what if we just backed up one basically by saying apply map matrix? What does that do? That means I'm basically taking the matrix, but I'm now taking each element out of the matrix. So basically that means if the matrix was a 3 by 3, with 3 matrices under, so the matrix is 3 vectors, v1, v2, v3 underneath it, right? Then if I apply on the map of the matrix, then I'm basically saying the map of some function of v1, v2, v3. Not this, but, whoa. God dang it. How the hell? I did something with shift that caused it to just... Oh, you suck. And you double suck, because now you've... Ah! Alright. Okay, I don't mind the bigger font, actually. That's not that bad, but... Oh, well, that's fucking terrible. What dim bulb thought this was a good idea? Okay. Okay, how do I size it down? Control Shift minus? No, that's my undo. Control. Well, that just gets worse and worse, doesn't it? All right, Control Shift plus does make it bigger, but how do I make it smaller? Oh, there you go. Ugh, what a... Okay, all right. So I put this here. Okay, there we go. All right, cool. But I can't undo it because I'm not Emacsy enough. All right, so I'll just recopy this again. Thanks a lot. Okay. So we'll have to think of our own examples, but I think I had an idea, which is invert matrix. Nope, I keep saying that for some reason. Rotate matrix. I don't like this problem already. Matrix, and we're going to rotate the matrix. We can just call it M. I prefer to call it matrix. All right, and so the expected. Let's get one example on here. So it is okay. Actually, the expected of the empty. Is that even a valid matrix? The empty should return the empty. The empty 1 should return the empty 1. The empty 1, 2, which means it also needs to be a square. It needs 3, 4, should return... I wish there was a way to do this, but there's not. I guess let's do the best we can, yeah. It should return, let me think about it. Which way are we rotating? We're rotating 90 degrees. Okay, so that means the 1 should go where the 2 currently is, right? Okay, so I don't know. I guess, and that means the 3 should go, so it's 3, 1, maybe. And then, holy crap, I suck at this. All right, and then 4, 2, I think. And we probably need an odd case too. Okay, so, oh man. Is there a way to just check? Oh, you know, you can copy that example we saw. Rotate a matrix. No, I'm not looking for a solution, I just want an example. Oh, I guess we can just copy the... Okay. Here's a big one. Okay. Not even close. Okay. Alright, so we put that whole thing under this. Okay, so because this is just starting to get too ugly, I'm just gonna space them out. Does that look right? Okay. If we rotate 90 degrees, the 1 went there, the 2 went down, the 4 went across to the left one, and the 3 went up. I think that's right. Okay, so final copy on theirs is... I mean, I could do this by hand, but why do that? I mean, I could just assume this is probably right. Alright. And... okay, so that's a bunch of test cases. And how can we rotate? Well, I have a suspicion that something with looking at a higher level than the level of the matrix and sequencing that might do something. I'm just curious what will happen if we apply a map on the matrix with some function, but I'm not sure what. What if we just vectorize this function? What happens? Huh. I know what's wrong. I just ran the previous one. I was like, that is unbelievable. Alright, so that's interesting. Yeah, the empty matrix can't be done with that. So basically nothing works, I think. The 1x1 matrix oddly enough worked, but what did I get? I got 1, 2, 3, 4. Rotate matrix. Right. Wait, is that right? That's maybe the wrong expected. I think. Oh yeah, I got it backwards, don't I? I kind of don't like the R in the sense that I feel like it should be input and then output, you know, but it's actually expected first, then effectively input rest, you know. I don't know. It's a thing. Okay, so the expected was 3, 1, 4, 2. I passed in 1, 2, 3, 4, but what I got was 1, 3, 2, 4. Wait, that's the exact same thing. What I got was 1, 3, 2, 4. So I'm basically... No, actually I didn't get the exact same thing. I got 1, 3, 2, 4. That's weird. what did I do? I did a map on the matrix, and so I'm basically converting each row into columns and each column into rows. That's not the same thing as rotating by. I don't know what I did because I don't know the math for it, but I converted the rows into columns and the columns into rows is what I did with that. That wasn't what I wanted to do though. Well, so much for my niggling at my brain thought. I think this just converts the rows into columns and the columns into rows. So let's actually check that that's what it does. 1, 3, 2, 4 is the result. So it did like, oh, that's weird. It actually just took it backwards. How did it do that? Okay, so apply map the vector of the matrix. Taking the map function takes the vector as a function. Our matrix was expanded out into its rows. This is the matrix. This basically is the equivalent of map vector the rows of the matrix. And so it's processing those rows one row at a time. The rows are coming in. The rows are 1, 2. So how did it end up with 1, 3? Because it's calling the vector on each item. Oh, I see it. Okay, yeah. So basically, it literally just I don't know what to call it, but yeah, it converted the rows into columns. Basically, is what that did. That's interesting to know. But how do you rotate a matrix? Well, I mean, I guess there's the logical idea of a rotation. What does it mean to rotate something? A matrix, I mean to say. Obviously it means to turn it by 90 degrees. But like, what happens to the index positions when you rotate? It's like in the case of the one element matrix. 1, 1 becomes 1, 1. That's easy. What about the 2 element matrix? 1, 1 became 2, 1. No, sorry, I'm reading the thing backwards. Yeah, 1, 1 became 1, 2. Sorry, I'll just map over. 1, 1 became 1, 2. 1, 2 became 2, 1. 2, 1 became 1, 2. And 2, 2 became 2, 1. I don't see a total pattern there, honestly. I think I have to write it out. Just happens to be 4 rows, so we can just do them right here. 1, 1 became 1, 2. 1, 2 became 2, 2. 2, 1. Let's go sort of around, 2, 2 became 1, 2. And 2, 1 became 1, 1. Is there any clear pattern here? Two, one became 1, 1. I think I need to just read about how do you rotate a matrix. I need a children's guide to rotating a matrix. Oh man. Oh man. So I'm kind of dumb, but why do you need to get the sine and the cosine and stuff involved in matrix rotation? I don't know. Oh, that's a good way of thinking about it. The first row does become the last column. The second row turns into the second to last column. Is that true? 1, 2, 3, 4 becomes 1, 2, 3, 4. 5, 6, 7, 8 becomes... Oh, I never saw it that way. Yeah. So I feel like maybe there is hope for me with this then, because otherwise I was just gonna have to like, not really solve it because I'm just gonna copy enough stuff that I haven't really intuited or understood anything other than just being able to parrot stuff. But that is an interest. I hadn't actually noticed that with this, but yeah, 1, 3, 1, 2 becomes 1, 2 here. 3, 4 becomes 3, 4 here. Duh. But okay. So if I can somehow convert my rows into my columns, right? Which I think I can do actually with that guy I had, right? He converts rows into columns. No, he literally... Well, anyway, we don't need this. This didn't help. Actually, I'll just back up the whole thing. This guy literally converts rows into columns, which isn't the same thing. Wait a minute, am I almost there already? Maybe I just need to reverse these. Let's see about that. I mean, map reverse. Actually, we can convert it to map v reverse. Whoops, we gotta actually thread that if we want to use it that way. What you got? Okay, so this guy is flat out failing. But the cool thing is my 1, 2, 3, 4 did work, but this guy does not work. That's too bad. I thought that'd be cool if that worked. 14, 10, 6, 2. 13, 9, 5, 1. What's the issue? Well, I feel part of the issue is it just got too big too fast and I can't even understand what I'm reading. So let's back up one and just do 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the input, the matrix. We also want the output, which I'm so bad at this, but so I think, yeah, it just becomes 1, 2, 3. They said that the first row becomes, so let's see, 4, 5, 6. Does that seem right? Let me just finish it off. 7, 8, 9 is the output. Does that seem reasonable? So 1, 2, 3 ended up being 1, 2, 3 over here. The original 4, 5, 6 got rotated, so now the 4 should be here and the 6 should be here. The 4 is here and the 6 is here. The 5 is still in the center. The 7, 8, 9 in the input got rotated left, so now it should be 7, 8, 9. I think that's right. Now let's see if that works. Wait, why is everything passing now? Other than that first one, which is... Wait, what did I do? Oh, I commented out, that's what I did. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wait a minute, this isn't right, is it? Did I copy the wrong one? 1, 2, 3, 4 should be on this side, right? What the hell is this nonsense? Have they rotated 270? So 1, 2, 3, 4 would be, 1 would start here, 1 rotation, 1 would be here, 1 rotation, 1 would be here, 1 rotation, 1 would be here. This is the 270 of the matrix, I think. Let's see. Let's see if I can make it right. Alright, so this is... I just suck at this. Alright, 1, 2, oh my gosh, 3. Oh man, Steve, 4. Alright, so that's the first row, became the last column. The second row becomes the second to last column. 5, 6, 7, 8. Does that make sense? It won't make sense. I can't even eyeball it until I fill in the whole thing. 9, 10, 11, 12, 13, 14, 15, 16. Holy crap, Steven. 16, there you go. Alright. Oh my gosh. Go practice Microsoft Typing Assistant, or whatever that little program was. What did I do? 16... I'm sure you made mistakes there. All right, 16, 15, 14, 13, 12, 11, 10, 9. Okay, I think that's right. 5, 6, 7. Feels like there should be 8. Okay. 4, 3, 2, 1. So does that feel sort of right? I couldn't even tell you, honestly. I know the 1, 2, 3, 4 looks right. I know previously the thing that was on the wall, which was the 4, 8, 12, 16, has now been rotated seemingly. Yeah, 4, 8, 12, 16. I know previously the thing that was on the bottom, 13, 14, 15, 16, is now here. Okay. And I know previously the thing that was on the left, 13, 9, 5, 1, is now here. What about the inner? It used to be 6 and 7 at the beginning. Now it's 6 and 7 this way. It used to be 7 and oh, it used to be 7 and 11. That doesn't look right, does it? 7 and 11 down, and now it's all not. Huh? That's interesting, isn't it? That is interesting. Huh. It's almost like you... That's not right. It's right on the outside, but it's not right on the inside. 6, 7, 10, 11. Right? It's not right on the inside, right? Okay, so that's funny because we've successfully rotated the inner matrix before. So why are we having issues? Do we need to drop the 2 off each piece of the matrix and then do something else in here? First of all, is everything in the center still in the center? Yes, 10, 6, 7, 11 are still in the center. So they haven't, like, shifted off somewhere. That would be really worrisome. Let's get this sort of lined up. This is just confusing. Let's just do it this way. All right. Okay. So 6, 7, 10, 11 are still in the center. But then 6, 7 here went to 6... 6, 7 here went to 6, 7 there. Oh, I just have so much trouble even seeing this. 6 here went 1 to the right. That seems right. 7 here went 1 down. That seems right. But 11 here went... Oh, wait, maybe it is right. Went 1 to the left. That is here. And 10 here went 1 up. That seems right. Okay, because the center point is this thing I can't put my cursor on in the middle right here. Okay, maybe that is right. Okay. Okay, wait. Oh, there you go. All right, so this is a... Why doesn't this work with this? It doesn't work because it's taking the nil. So it's a vector that contains nil. It is a vector that contains a vector. That's the empty matrix, right? The empty matrix... Is there a distinction between the empty matrix and the empty vector? The empty matrix, strictly speaking, is containing one value here, right? It contains... I'm not really clear about the semantics here. What if I do this, just out of curiosity, what happens? It blows up. Don't know how to create IC from closure core map. Okay. To me, this looks like the empty matrix, but it's not capable of handling it. That's odd, isn't it? Why is it not capable of handling it? Because I'm mapping over the matrix, but I'm pulling it apart, right? when I pull it apart, the matrix, the apply map vector matrix, which in our case the matrix is the vector of the empty vector, becomes effectively map vector just this, I think. The map vector of the empty sequence should just become an empty vector. Yeah, and then I reverse that empty vector. But why doesn't that work the way it works for the other ones? Why does it destroy a level when I do that? Whatever I did, let's undo that. There we go. Why does that destroy a level? Now that I don't get. Huh. This is not destructive, and that information has not been gained or lost here. We've just reversed it. So as long as you know that you reversed it, you can just reverse it back to the original. It does nothing. So that can't be the issue. The issue must be that we're sort of splicing out but why is the empty sequence different than the apply vector, map vector the vector. Map vector the empty vector. It's not quite clear why that is. It's like apply map vector matrix. Map the vector on the empty array. But why? What's the distinction between these two things? It shouldn't matter whether there's a value in here or not. It's still something about this. Verse, like for this guy, for the one element guy, what is he getting? He's really getting the map of the vector with one element. So he's reading through, grabbing the vector. I'm just not clear what this means, actually. I wonder if this is a notion in mathematics. In fact, a matrix, mathematically, is this equivalent to the empty matrix, or is this the empty matrix and this is the empty, I don't know what they call it, an empty map list or something, I don't know, sequence. Does this make sense as a concept? I don't know, but I don't know basically, yeah. So, MGS. But I think this does work, so let's actually just check one last time. Yeah, so cool. Accidentally. Alright, problem 1.6 of cracking the code, or so. Problem 1.7 of cracking the coding interview 6th edition. And yep, that's it.